Okay, folks, so today's video is about the evolution of the Earth's atmosphere. You might be surprised to learn that that is a sketch I've drawn with whiteboard pens. That is not a HD photo of the Earth. Anyway, starting as always with quick quiz. So if you want to pause the video now, and I will go through the answers in about 5 seconds. Make sure you actually pause it and have a go at these questions. 5, 4, 3, 2, 1. Okay, and now I mean actually pause it and do the questions because most of you didn't bother pausing it. I know, I've got very little faith. So actually pause it, do these. Right. Going through these answers. What is the test for carbon dioxide? So you bubble, can't spell bubble. You bubble a gas through lime water, and if it goes cloudy or milky, then the gas was carbon dioxide. What do these state symbols mean? S is solid, L is liquid, G is gas, AQ is aqueous or dissolved in water. Right, what is the word equation for photosynthesis? Yeah, I know this is a little bit biology, but it's relevant for today. So photosynthesis is carbon dioxide plus water goes to glucose and oxygen. Draw a molecule of O2, outer electrons only. So oxygen is in group 6, which means it's got 6 on its outer shell. 1, 2, 3, 4, 5, 6. O and O. And then so this one's got 1, 2, 3, 4, 5, 6, which means it's a double bond because now they've both got 8. And what is condensation? Condensation is the process where a gas changes state and turns from a gas to a liquid. Okay, so moving on to today's. So evolution of the Earth's atmosphere. So this is a whistle-stop tour taking you through everything you need for the Edexcel GCSE. So we're going to go back a few billion years, right? So Earth's like 4.5 billion years old, give or take a week. So we've got Earth is newly formed, and it is a super molten ball of rock, right? It's so hot because like space reasons that it's just molten big ball of molten lava, magma-y, bubbly badness, right? Not a pleasant place to live, and it has no atmosphere at all. No atmosphere. I should probably have said what an atmosphere is. The atmosphere is like the blanket of gas around the planet, right? Going back to the HD quality image I drew earlier. So we've got Earth, and it's got this thin layer of gas around the planet. It's not like a force field where it's like, yay, here loads of gas, here no gas. It gets thinner and thinner and thinner as the further away you get, right? So it's like lots of gas, bit less, bit less, bit less, bit less, right? So the atmosphere is the blanket of gas around the planet. So early days when the Earth was young, no atmosphere, super hot, bubbly ball of lava. And the reason there's no atmosphere is because it's so hot that any gas has got so much heat energy, so much kinetic energy, it can just escape into space. So it's like the atmosphere is actually like boiling off into space. So fast forward a little bit, and Earth cools down. D-W-O-N, down. Right. D-O-W-N. Right. Earth cools down. And so it cools down, which means the gas no longer has enough energy to escape. It's not quite a ball of molten rock anymore. Some of it's starting to solidify. You've got Earth, and you've got volcanoes, right? My volcano drawing. Let's add some lava to it. Yay. Right. So, not to scale. And from those volcanoes, it is spewing out lots of carbon dioxide. So we've got lots of carbon dioxide. For the rest of this video, to save time, I'm going to write it as CO2. So we've got lots of carbon dioxide, CO2. Quite a lot of water vapor. not liquid water, water vapor. So H2O, but it's a gas. So carbon dioxide is also a gas. Remember, Earth's cooled down, but it's not like at the levels it is now. It's still very hot. So the water is all water vapor as a gas. There are small amounts, like trace amounts of other gases. Trace amounts of other gases. I'm not going to go into them in this video because you don't need to know them for GCSE. So you do need to know that there were small amounts of other gases, but you don't need to be specific. And really importantly, there was no oxygen. So there's no oxygen at all, right? So we've got carbon dioxide and water vapor and other gases, and they've all come from volcanoes. Okay? Right. Next step is Earth cools down even more. Woohoo! Right, Earth's cooled down more. So we've got Earth. It's cooled down a bit more. And as the temperature gets to below 100 degrees, so the temperature is now less than 100 degrees, see, which is obviously the boiling point of water. The atmosphere changes because the water vapor, this is why I put this in the quick quiz, right? Water vapor condenses, which means it turns from gas to liquid. Essentially, it's raining. Rain. But on the exam, refer to it as, don't say it rained, say Earth cooled down and say, so the water vapor condenses. So, yay, rain. And so it rained a lot. So what has that done to the atmosphere? It means the amount of water vapor, H2O gas, the amount of water vapor in the atmosphere has decreased. Why? Because it's condensing and it's raining and it's forming oceans. Like, it's literally raining so much. It's where we got all the oceans from. Okay, so that has also done something else. Because if you remember, in the atmosphere as well, there was lots of carbon dioxide, CO2. But carbon dioxide dissolves in water. So it's cooled down, water vapor's condensed and formed all the oceans. And then the carbon dioxide starts to dissolve in the oceans. Not all of it, but a lot of it dissolves in the oceans, which means the amount of carbon dioxide in the atmosphere also decreases. Why? Because it's dissolved in the newly formed oceans. Okay, next step. Running out of whiteboards. So next step is super miracle that I'm not going to go into the reasons here, but we get life. Yeah, life evolves. Nothing complicated, just really primitive plants. Primitive. Simple, early plants. So primitive plants, like single-celled plants and stuff. Plankton, like that sort of stuff. Maybe not plankton. I'm talking about stuff I don't quite know. Early single-celled plants. And plants, this was another reason why I put it in the quiz. Plants do photosynthesis. Photosynthesis. Yay! And if you remember from the quiz, photosynthesis, it turns carbon dioxide and water into glucose and oxygen. So photosynthesis means the amount of carbon dioxide in the air decreases because the plants are using it up. And then they're producing oxygen, which means the amount of oxygen in the air increases gradually. And that takes us to the atmosphere we know today, right? So whistle-stop tour through all of it. We had, so if I have, right, the atmosphere at, can't spell, atmosphere. So at first there was zero atmosphere. Why? Earth was super duper hot and all the atmosphere was boiling off into space. Then Earth cools down a little bit, and the atmosphere is carbon dioxide, water vapor, and some other gases. That is because Earth is cooled down. Where are these all coming from? They're coming from volcanoes. Right, what happens next? Earth cools down even more, and all of a sudden you get a lot less water vapor. Why? Because it's condensed and formed the oceans. And you get a lot less carbon dioxide. Why? Because it's dissolving into the oceans. This is all about the oceans being formed. And then you get, all of a sudden, you get even less carbon dioxide, and you get more oxygen. Oxygen's only just start to emerge. Why? Because life has evolved, and primitive plants are doing photosynthesis. So there's our whistle-stop tour through the atmosphere. I am just going to take you quickly through some chemical tests, right? And I know one of these was in the quiz. So this is lime water. I'm going low tech because my source for carbon dioxide is me. So if I'm just going to literally breathe out into the lime water and blow bubbles into it, and you should see it start to change colour. I realise this is thrilling. Maybe I should speed or edit this out. Is it starting to change? It's starting to change a little bit. Okay, it's starting to go a little bit cloudy. I'll do one more lot. Right, not going to bother anymore, but you can see it's gone like cloudy, milky colour because of the carbon dioxide. Another one that you hopefully know. So let me just light the splint first. So we've got, try and do this one-handed. So we've got hydrogen, and so test for hydrogen is lit splint, and should do a squeaky pop. Nice squeaky pop test. I've got a couple more, so I might as well use them. So hydrogen, lit splint, and third time's the charm. There we go. Lit splint does squeaky pop. Right, test for oxygen. Oxygen, the test is, you have to be careful with the wording of it. It relights a glowing splint. So this splint is lit. When I blow it out, if you can see, it's glowing. It's not lit anymore. You don't use the phrase blown out, you use glowing. So if I put this into pure oxygen, it relights. Okay, so oxygen relights a glowing splint. I'm not actually sure if I got that on camera. So I've got my lit splint. I'll blow it out, but we don't use the phrase blown out. We use the phrase glowing. So this is a glowing splint. And then if I put it into pure oxygen, it relights. And then knowing those tests, I mean, hopefully you've already knew the squeaky pop test for hydrogen and the carbon dioxide lime water test, but the test for oxygen, it relights a glowing splint, comes under the Earth's atmosphere topic. And that's it for today.